Every time we look up at the night sky, we are looking back in time. The light from distant stars has traveled for thousands or even billions of years to reach us. But even then, we are only seeing part of the picture because there are two great barriers to our view. The first is swirling cosmic dust, which hides everything behind it. The second is the steady expansion of space itself, which stretches light beyond our visible spectrum and into the infrared. For centuries, these barriers have allowed the universe to keep its deepest secrets hidden. We've never seen the first galaxies or witnessed the earliest stages of stellar formation. But on Christmas Day 2021, all that changed. We finally launched the so-called Golden Eye that would allow us to lift these cosmic veils forever. The James Webb Space Telescope, a $10 billion three-agency collaboration, Webb is the most powerful observatory ever constructed. Equipped with ultra-sensitive infrared detectors, it's not only able to peer through the dust, it can see even the faintest and most distant objects. This telescope has revolutionized how we see our universe. We've seen wonders close to home, auroras blazing across Neptune and the iconic pillars of creation. And those further afield, gravitational shock waves and galactic collisions, to name a few. But Webb wasn't just created to send back pretty pictures. As of 2026, it has already completed more than 860 scientific programs and collected nearly 550 terabytes of data. That's more data than Hubble accumulated in 35 years. These datasets are revealing a universe far stranger and more complex than we ever imagined. Becoming fully operational in July 2022, the James Webb Space Telescope was designed for one primary mission: to use its sensitive infrared detectors to pierce the cosmic dust clouds that permeate the universe, allowing us to observe the very first stars and galaxies. And it's off to a good start. Already some of its early findings are pushing the boundaries of what we thought we knew, challenging current models of how the universe has evolved. But to look that far back, James Webb has to peer through a lot of space. And along the way, it's made some remarkable discoveries around more familiar objects, ones that are only visible at infrared wavelengths. So let's take a trip across the cosmos and back through time, starting in our solar system and traveling to astonishingly distant early galaxies, all through the incredible eyes of Webb. Our first stop is in our own cosmic backyard, Neptune. Whilst it's usually easily recognizable thanks to its blue hue, with Webb it looks rather different. Doesn't it look ethereal? The methane in Neptune's atmosphere absorbs almost all of the infrared component of sunlight, meaning very little is reflected. There simply isn't much for the James Webb Space Telescope to pick up, making much of the planet appear dark. But this does have an upside. Instead, it allows the subtle, faint glow of Neptune's dusty rings and high-altitude clouds to stand out in dramatic detail. These are the clearest images we've ever taken, now joined by the first-ever detection of its auroral glows, dancing at unexpected latitudes. Not only beautiful, they've also revealed previously unseen ring arcs and shown us 14 of the ice giant's known moons. And this is just the start. Scientists are still poring over these images to uncover more of Neptune's secrets. But for now, other secrets of the outer planets will have to wait, as Webb has been focusing its attention on one of the most compelling objects currently in our solar system, one that didn't start its life here. On recent observations, Webb used its near-infrared spectrograph to probe distant comets and interstellar visitors carrying chemistry from alien stellar nurseries. What it found has opened up a Pandora's box of possibilities. These objects turned out to be unusually rich in carbon dioxide and water vapor. In fact, the ratios were among the highest ever observed, hinting at formation in exceptionally cold outer disks around other stars. It is a messenger from another star system, having formed where temperatures allowed exotic ices to condense in ways rarely seen here. By directly sampling these pristine relics, James Webb has proven that the basic building blocks of planetary systems and life are shared across the galaxy. The common elements and chemical processes that created our solar system are likely universal. But this extraordinary telescope hasn't just proven useful in exploring worlds in our cosmic backyard. It's also part of the hunt for new worlds beyond our star. And yet again, it's making some astonishing finds. The search for exoplanets is well underway. Thanks to missions like TESS and Hubble, we've already found more than 6,000 of them. But they've only been able to gather so much information. To find out more about these strange new worlds, they needed another instrument, and that came in the form of James Webb. It's found that even our closest star has been keeping secrets. Just over 4 light-years away lies the Alpha Centauri system, a trio of stars that includes 2 sun-like stars and the red dwarf Proxima Centauri. For decades, astronomers have suspected that planets might orbit the 2 sun-like stars, but the immense overlapping glare of the binary pair made them impossible to detect. Webb has overcome this obstacle, using its mid-infrared instrument and an internal coronagraph to block the intense starlight. Much like you might use a car's visor to block direct sunlight so you can see on the road, this device stops the bright starlight and allows the faint light from the planets around it to be seen. This is an incredibly challenging observation, requiring meticulous image processing to subtract the residual light from both Alpha Centauri A and its companion star B. The resulting faint point of light detected by MIRI is now the closest ever exoplanet candidate to be directly imaged. It has given us strong evidence of a Saturn-mass gas giant orbiting Alpha Centauri A. And even more surprisingly, based on orbital simulations, this gas giant likely follows an elliptical path within the star's habitable zone. While a gas giant itself would not be likely to host life as we know it, its existence confirms that a planetary system has formed around our nearest stellar neighbor, providing the potential for smaller, habitable moons or other terrestrial worlds yet to be discovered. Now, if planets and moons form throughout the universe, which we very much think is the case, the next question is, how? And this is once again something the James Webb Space Telescope can help answer. So, let's continue our journey by diving into the immense chaotic processes of creation. The cosmic cliffs, part of the Carina Nebula, 7,600 light-years away, and the iconic pillars of creation, in the Eagle Nebula, 6,500 light-years away, may be familiar sights to some of you, thanks to the stunning visible light images captured by the Hubble Space Telescope. But Webb has given us an entirely different view. Rather than competing, Webb acts as Hubble's companion, using the infrared part of the light spectrum to peer through the thick, obscuring dust that Hubble's visible light can't penetrate. In this image of the pillars of creation, Webb's NARCam view reveals thousands of previously unseen stars, including newborns that were completely hidden within the dark, dusty columns in Hubble's images. They appear as bright red orbs lying outside one of the dusty pillars. Estimated to be just a few 100,000 years old, the red glow comes from energetic hydrogen molecules created in plasma jets and shock waves emanating from the new star within. It's as if the top of the pillar is pulsing with activity. Similar processes have also been seen at the cosmic cliffs. Here, Webb's NARCam has captured crisp details of the turbulent gaseous structure at the edge of the nebula. This sharper look reveals that they are actively being sculpted and eroded by intense radiation from massive young stars just above them, a process much harder to visualize in Hubble's previous data. This new ability to peer inside these cosmic nurseries fundamentally changes our understanding of how stars and planets are born, finally allowing us to put theories based on simulations to the test. And what Webb is finding is that infant stars are not calm. Their births are explosive, energetic, and always spectacular. Deep in the outskirts of the Milky Way, in regions of low metallicity far from the galactic center, our golden eye found something extraordinary, a true behemoth of a protostar, weighing as much as 10 times the mass of our Sun or more. But not only that, this massive star is unleashing huge jets of gas and radiation. Known as a bipolar outflow, they are created as superheated gas falls inward toward the protostar's core and is then simultaneously blasted back into space. Powerful magnetic fields channel this material into narrow, high-velocity jets launched outward at hundreds of kilometers per second. Spanning 8 light-years or more, these spectacular birth announcement jets are immensely powerful, acting like a cosmic snowplow, pushing away the surrounding molecular cloud material and creating two much larger opposing lobes of gas. This is a rare example of what's known as a Herbig-Haro object, bright patches of gas and dust that form when these jets collide with surrounding material. Although many Herbig-Haro objects have been observed so far, these jets are particularly rare due to their immense size and strength in pristine environments. The stable, symmetrical nature of the outflow suggests the star is forming via an ordered disk, which provides crucial evidence for the core accretion model of massive star birth. What makes this discovery even more exciting is the fact that it's located in a star cluster on the far edge of the galaxy, where metallicity is extremely low. This means it has far fewer heavy elements than our Sun. And by heavier elements, we mean anything beyond hydrogen and helium. This pristine environment almost perfectly mirrors the conditions of the early universe. By gazing through its infrared lens, Webb is giving scientists crucial clues to something that has long been a mystery: how the very first massive stars may have formed. But stellar birth isn't the only part of the creation process we don't fully understand. Planetary formation is equally mysterious. And yet again something the James Webb Space Telescope is illuminating for us. Once a young star settles, the chaos around it begins to organize. The remaining swirling dust and gas become a protoplanetary disk, the birthplace of planets. As giant planets emerge within these disks, they can form miniature disks of their own. One example comes from young systems located hundreds of light-years away. This massive young exoplanet is encircled by a circumplanetary disk, a dense ring of material considered a moon assembly site. It's how we believe Jupiter's moon system formed long ago. Using its MIRI instrument, Webb delivered the first direct measurements of the chemical and physical properties of this potential moon-forming disk. Researchers discovered that the disk is carbon-rich, containing complex organic molecules like acetylene and benzene. This finding represents a major breakthrough, as this carbon-rich chemistry is in stark contrast to the disk surrounding the host star, where scientists detected water but virtually no carbon. This chemical difference, seen in a system that has only been evolving for 2 million years, allows us to compare the ingredients for forming moons in a distant system to the formation of our own solar system over 4 billion years ago. The universe is busy making worlds, and Webb is giving us an unprecedented front-row seat. Now, we've seen how individual stars are born and how planets begin to take shape, but these stories don't happen in isolation. They play out across the vast, breathtaking structures of entire galaxies. In recent years, Webb focused on dozens of nearby spiral galaxies, delivering images that are simply astounding. Forget the science for a moment and just look at them. If that isn't art, I don't know what is. You are looking at the heart of cosmic creation. In a galaxy like NGC 628, also known as the Phantom Galaxy, located approximately 32 million light-years away, Webb's view is special because it highlights specific galactic ingredients. The blue light marks millions of older established stars clustered in the galaxy cores, but it's the incredible red and orange that demands attention. This is glowing dust and gas, nursery material that threads through the spiral arms like fiery motorways. The bright red areas are stars that haven't fully formed yet, still encased within their dusty peaks. You can also see that the spiral arms are filled with giant spherical shells or bubbles, massive holes carved out by the shock waves from ancient exploded stars. Analyzing these consistent patterns across multiple galaxies helps scientists understand how they build, maintain, and distribute the material necessary for stars, planets, and with that, life. But even now, with all this information, we still don't have the full picture. We have one step further to go. Instead of looking at fully formed old galaxies, we need to know how and when they began. And for that, we need to go back much further, to the very first stars and galaxies. It's time to travel back to the cosmic dawn, some 13.5 billion years ago. Even with the James Webb Space Telescope, with all of its spectacular technical advances, there are limits to what light can show us. The earliest light in the universe was released when space first became transparent, just a few 100,000 years after the Big Bang. Beyond that point, the universe cannot be observed with light. But luckily, physics gives us ways to see farther than we otherwise could. Gravitational lensing. We see this effect when a massive galaxy cluster is in James Webb's view. This cluster is so heavy that its gravity warps space-time, acting like a cosmic magnifying glass that bends and focuses the light from galaxies behind it. In recent observations, Webb captured distant events behind such clusters, but the telescope didn't just see them once. Their light was split, creating multiple images of the same phenomenon. Because the light from each image took a slightly different, magnified route around the cluster, the events appear as echoes across time. Analyzing the time delay between each one, or how much longer the light took along each path, allows astronomers to precisely measure vast cosmic distances. This data is critical for refining the expansion rate of the universe, also known as the Hubble constant. There's been some disagreement over this value in recent years, but who knows, maybe James Webb can help solve it with measurements like these. And so we have arrived at the very edge of the observable universe, close to the dawn of time. Here, Webb's NIRCam and NIRSPEC instruments, as part of deep surveys, have pushed observation to its limit. The challenge is that light from the earliest galaxies is severely affected by the cosmological redshift phenomenon. This occurs because the expansion of the universe stretches light waves as they travel across vast distances of space, shifting the light from the visible spectrum all the way into the infrared, exactly the kind of light Webb is designed to capture. It has uncovered galaxies that existed far earlier and are far brighter than we expected. And one in particular stood out. Webb confirmed its redshift, corresponding to just 280 million years after the Big Bang, making it the earliest known galaxy in the universe, a luminous beacon that looks nothing like what we predicted. The prevailing lambda cold dark matter cosmological model predicts that galaxies at this epoch, often referred to as the cosmic dawn, should be small, dim, and only just beginning to form their first, simplest stars, which is almost the opposite of this new discovery. These galaxies are too mature, too soon. To grow structures this large and chemically enriched only 280 million years after the Big Bang, the early universe must have been forming stars far faster and more efficiently than any current model allows, or perhaps seeding massive black holes through direct collapse or other exotic channels. Adding to the shock are compact red sources known as little red dots, scattered across these early fields. dense, dusty objects that appear to harbor rapidly growing supermassive black holes, or even black hole stars enshrouded in thick gas envelopes, allowing accretion at rates that should be impossible under standard limits. Further evidence comes from early mergers of multiple galaxies, flinging oxygen and heavy elements into vast halos far sooner than expected, and dusty star-forming systems already rich in metals when the universe was barely 1 billion years old. The very existence of these objects forces astronomers to confront the possibility that the foundations of modern cosmology need a serious revision. One explanation for this contradiction revisits bold ideas of objects powered by dark matter annihilation, or primordial black holes lighting the universe before fusion even began. These potential first structures could grow enormous, cool, and long-lived, producing the infrared signatures Webb specializes in. So we could be looking at the signatures of mechanisms that let the cosmos assemble complexity with breathtaking speed. This fundamentally connects the most distant observations to the least understood components of our universe. So yes, the James Webb Space Telescope has literally shed light on our universe in a whole new way. It has revealed a cosmos richer and more complex than we ever dared to imagine. The James Webb Space Telescope has peeled back the veils and shown us a reality that delights in defying expectation, where the impossible becomes the new normal and every discovery rewrites the rules of cosmic possibility. In unveiling structures and processes that our models insisted could never form so soon or so perfectly, it reminds us that the universe is not bound by our assumptions, but forever capable of greater wonder. What other impossibilities are waiting in the infrared glow of the cosmic dawn? Ready to transform how we understand our origins and our future among the stars? If these revelations have stirred in you the same awe and hunger for truth that drives every great exploration, subscribe now to journey deeper into the unknown with each new unveiling. Comment below with what this defiance of the cosmos means to you and how it reshapes your sense of humanity's place in the infinite. Share this voyage with every curious mind you know, so they too can witness the universe breaking its own rules. And together let us keep looking up, questioning boldly and embracing the magnificent unknown that binds us all.